How's it going, guys? All right. Good morning. Happy Friday. Hope you're all doing well. Don't forget about this assignment. It's due on Sunday night. I made it due on Sunday night because of the eights problem. I have a couple of announcements, and then I'm going to be teaching the first lesson in our book today. And yesterday, I ripped apart my pre-cal class because I put them in groups, and they were supposed to be looking through the book, and they didn't have the book. So one person went out to their car, one person went to the kitchen. And I was thinking, this is crazy. So I looked at my syllabus, because I was telling them, you guys need to follow my syllabus. You need to have your materials. You need to. And here, come to find out, I looked at the syllabus for Honors Algebra 2 and Pre-Cal, and I didn't put the book. So I have to apologize to them tomorrow. But just a reminder, you need to have all your materials with you. That includes your book. So can I see your book? Can you guys hold up your book, please? Yep. Can I see your book? If you don't have your book, go get it. Hurry up. I need to see your book, please. Angel, I got you. Alessandra, I got you. Isabel. Samantha, I got you. Andrea, got you, hun. Got you, Manuel. I got you. I need to see everyone's book, please. If I didn't call your name, I want to see your book. If you don't have your book, go get it. Thank you. Alexis, I got it. All right, listen carefully. Thank you, Guadalupe. I know this is a weird thing, but you've got to know that when you're in class, so when you come to class, don't be late. When you come to class, have all your materials, right? So you need to have your book. You need to have a pencil. You need to have paper. You need your notebook. You have to have a calculator. Okay, when I start teaching, you should have all your materials there. Okay, listen, I don't want you laying in your bed. I don't want you laying on the floor. You can sit on your floor. I mean, when I got my master's, I got my whole master's sitting on the floor. I still sit on the floor, grade papers. But what you can't be doing is laying on your bed, because when I say get out your assignment, when I say take notes, when I say get out your book, everything has to be around you, and you have to pretend like you're in class. And I hope I'm making myself perfectly clear, because I'm going to start flipping out about this. So you are in class. When I put you in groups, you have to be there, and you have to show, when you're in your class meetings and groups, you have to show your video, and I have to see your face, and just like I would in class. Okay, so try to get into routine. Try to, get up and get ready, get your stuff together, and act like you're in class. I hope I'm making myself perfectly clear. All right. The other thing is, even though we meet 3 times a week, you're expected to do math every day. So it doesn't matter that we're meeting 3 times a week. So you should be doing anywhere from 20 to 25 problems per day. So there's no free days. I'm distracted because I'm looking at Diana's kitty. There's no free days in this class. So this is a college preparatory course. This is the course you need to go into pre-calculus and calculus. So anyhow, make sure that you are working every day in this class. All right, when I was writing the key for this assignment, don't forget that you have to grade your paper. You have to have the answers. Practice doesn't make perfect. I know you've heard that your whole life, but that's a lie. It's perfect. Practice makes perfect. And you have to grade your papers. If you don't grade your papers, there's no way of knowing you're going to get it right on an exam. Right? So I did the key for this, and I put it in Google Classroom. Make sure you grade your paper. Make sure you make the corrections at the end. Somebody asked me, well, how many corrections do we make? I mean, the more corrections you make, the better chance you have of getting them right on an exam. So when I was going through doing the key for this, I want to remind you that you are not putting the problems in the calculator. When you get more difficult problems that won't fit in the calculator, what are you going to do? I mean, you have to do these problems by hand. So you can use the calculator to add numbers like 214 and 35. You can use the calculator to multiply numbers. I don't care, but you're not working the problems. You're not evaluating the problems on the calculator. Do not do that, or you're going to be in trouble later on. Okay, so make sure you're just using the calculator to add big numbers, something like that. Also, I want to make sure you guys do understand what something like this means, right? On the calculator, you can use the caret key. So the caret key is on the right here in black. So 3 caret 7 means 3 to the 7th power. So if I were going to put this in the calculator, 3 caret 7 is 2187. So you wouldn't be expected to do something like that by hand. You could use a calculator. All right. So the first thing we're going to do today is I'm going to go through and see if you have any questions about review 2. So that means if you have questions about the crossword puzzle or the 8s problem, I can do that. Then I'm going to show you your online textbook and all the resources that come with it. And then I'm going to start a lesson today. Actually in module 1, lesson 1. So, okay. Does anybody have, this is review 2 due on Sunday night. Anybody have any questions, or anybody want me to work a problem either on the crossword puzzle or the 8s problem?
Number 8 on the crossword puzzle.
Okay, 8 across or down? 8 across or down?
Across.
Some of you have your mic on, and I need you to turn it off because I'm getting too much static. All right, when you work a problem like this, see this long division bar? Just act like it's 2 different problems. So just work the top as a problem, work the bottom as a problem, but work them simultaneously, which means together. So on the top, you have 12 squared, and on the bottom, you also have a 12. Over here, inside the parentheses, would be 12 to the 1st power. Now, do you guys remember about multiplying fractions? When you multiply fractions, you can cross cancel. And remember the other day we were talking about always simplify at the beginning to simplify our life, to simplify the problem. So that's what I recommend you do, is cross cancel And then 12 times 12 is 144. So this would be the most efficient way to do this problem. There are other ways to do it. This is the most efficient way. And up till this point, none of the other classes have really talked about doing problems efficiently. You have to do things efficiently, and I have to train you because your tests are timed and you don't have 2 hours to take a test. So you must do things efficiently so that you can get through a time test. All right, other questions?
Can you do number 13 across, please?
13 across. Okay, there's a bracket, 100 divided by the quantity 5 minus 3 plus 20, close parenthesis, minus the square root of 100. All right, according to the order of operations, PEMDAS, or please excuse my direct salad, we do what's in the parentheses first. And in the parentheses would be inside the parentheses. So the first thing we want to do is this, 5 minus 3 is 2. And these would be regular parentheses now. Minus, and since that's just separated by adding or subtracting, we can evaluate the radical if you want. And remember, 100 is a perfect square. So 10 times 10, 10 gets to come out. So now we're still following the order of operations. Inside the parentheses, we're going to divide. So 2 times what is 100? 50 plus 20 minus 10. So we have 70 minus 10, which is 60. All right. Other questions?
18 down.
18 down. Okay, this is the absolute value losing my place plus the quantity 3 times 4 quantity squared plus 7 squared minus 9 times 2, and I'm going to write it like that. I'm sick of using these dots. I'm trying to avoid the dots. Dots are confusing, and it's just better to use parentheses. All right, so we're going to do what's in parentheses first. So this would be, and we could do what's in absolute value also. So remember, 9 is a perfect square. So a 3 gets to come out, but there's still a negative there. Plus 12 squared plus 7 squared minus 9 times 2. Okay, now, exponents, because there's nothing more to do in parentheses. So the exponents, you can get him out of there. You can get him out. So remember, anything coming out of absolute value, which is distance, is a positive. And then the 12 squared would be 144. 7 squared would be 49 minus 9 times 2. All right, so now we're multiplying from left to right. So this is 30 plus 144 plus 49. A negative times a positive is a negative. Now remember what I said about this, put all the positives together and the negative. So this is what you would use a calculator for. Okay, so can somebody put this on your calculator, 30 plus 144 plus 49, and tell me what you get. Let's go. Somebody do it on the calculator. 30 plus 144 plus 49.
223.
223.
Thank you. Okay, let's
223.
subtract. What's 223 minus 18?
205.
205? That is correct. So if you're wondering why does sometimes I follow the order of operations, sometimes I kind of don't. Whenever you have plus or minuses, they're kind of like, I'm gonna explain this. It's like order of operations within themselves. So I could have done this because this is like one part, this is another part. There's like 4 parts to this. And I could have done them all separately. And I don't want to confuse you about that, but since you've seen the order of operations a lot, I would never say that to an Algebra 1 class because that would totally confuse them. But if you know what I'm talking about, fine. If you don't worry about it. All right. Is there any, I'm done working these now, unless, are there any like pressing questions of a problem that was just really bothering you? If there is, I'll work it. Otherwise, I'm going to go on. Okay. I'm hoping that you guys, that a lot of you know each other, and I'm also hoping that you're able to collaborate through social networks. You're going to need each other, and you're going to need to talk to one another, and I do encourage that highly. The more communication you have with each other, the better. So I'm hoping that you guys are connecting, and I'm hoping you're working together. Also, if you don't know a lot of people, we're going to be working, when we work in the groups, try to get to know one another, try to get other people, you know, your classmates' information, so that, especially if it's somebody you love working with, you know, some people can be just nice people, but you know, I have a couple of colleagues myself that I don't understand a word they say. And it has nothing to do with them. It has to do with, we're just totally at different planes or something. But then sometimes I work with people that it's really easy for me to work with them because I understand everything they're saying. So you want to find the people that you really connect with and can work well with. It kind of have the same learning styles. That's what I'm trying to say. So try to find people that have the same learning styles, that connect with you best. Okay. All right. What I would like to do now is, I'm going to take this down a little bit. I want to show you your online textbook because it's more than just a textbook. It's an interactive book, and it's a very powerful tool. I didn't realize this because most of the time I'm teaching math and I'm not messing around with technology. But since we've been forced into this distance learning, I've been able to explore my HRW a little bit. So I'm going to put in Google Classroom, I'm going to put the directions on how to get to my HRW, which is your online, your interactive textbook. But I'm going to share my screen with you right now, and I'm going to show you how you're going to do it. And then we're going to look at it. All right. All right. I don't know where my CHS went, so I'm just going to type it in here. You want to go to the Colton High homepage. I know you're familiar with this. And you're going to go to Let's Go. Then you're going to click on Class Link. Now see, this is the route you want to take because the district has set up your accounts through these links. So Colton High webpage, Let's Go, and then you're going to go to Class Link. sign in with Google. And now we're going to look for my HRW, which is right here. So what I'd like you to do is I want you to mess with this weekend and let me know if you're not able to access your account, because they promised me that they were going to upload all the rosters for my students and that you all would have your accounts. So once again, Colton High School homepage, let's go, class link, go to my HRW. You're going to use your account. And there we go. So this is what the dashboard looks like for my HRW. And you wouldn't have this, but I'm gonna go into Algebra 2. And what you're gonna wanna pick is the Interactive Student Edition. Now your dashboard looks a little bit different than mine because I'm the teacher, but now it's gonna look pretty much exactly like yours. So here's your book. And what we're gonna do is we're gonna start with Unit 1. I'm gonna be teaching this lesson today if we have time. Analyzing functions. And the first lesson is lesson 1.1, domain, range, and end behavior. So we're just gonna go there. All right, now don't go to get started, forget that. You see this little arrow up here? This is where you wanna go. This is where all your resources are gonna be. So you click on this arrow, and this looks exactly like your book. So if you open up your book to the first lesson, you're gonna see engage, explore, explain, elaborate, and evaluate. Now, I don't really use the engage a lot, but explore, sometimes I'll tell you, make sure you read the explore. Let's look at it. Make sure you look at the explore because it might be a review of Algebra 1. And there's little things you can click in here.
Complete the table by writing the finite interval shown on each number line as an inequality using set notation and using interval notation.
So I haven't taught this yet, but you could actually go through here and fill in the blanks and actually practice. So this is kind of cool because like I said, you're inputting answers and it will check for you if you're doing it correct or not. All right, these explains, these are going to be the concepts I'm going to be teaching. So I'm just going to click on this. Okay, this is your actual book. And you can read through this if you like. You can check, you can look at your answers. It'll ask you for problems. In fact, with the online textbook, you could actually go to your turn and try it out. Now, this right here actually looks like one of your test problems, but I'll show you an easier way to get that. But we haven't done this yet, so I'm not gonna look at that, but I'm just showing you how not only can you have somebody teach you, but you can try it out yourself to see if you get it. Okay, now this right here is what's important because I will be assigning problems out of your book, but I'm also going to be assigning problems out of evaluate. So I'll say that again. I'm going to assign problems out of your book, but I'm going to assign problems out of the evaluate, and I'll tell you why. These problems look like your exam problems. So if you do these problems and you practice these problems perfectly, you're going to get 100% on my exams. So if you look at this, you can get an example, you can work step by step, you can get the standards, but this is problem number 1. And like I said, I haven't taught this yet, but I'm just going to show you how this works. So this on this number line, with that being closed, this represents x greater than or equal to 1. So I'm going to take this and slide it over here. And now they want set notation, which I'll be talking about, which is this right here. So I'm going to slide this over here. And then finally, interval notation is what we're going to use most in Algebra 2 and pre-calculus. And so that would be this one. And I'll be talking about why that's that, okay? So now we want to know if this is right or not. I mean, we don't want to just go through this and hope it's right. We want to know right away. We want to self-assess. We want to know right away, is this right or wrong? Correct. So we got that correct. So now we can go to the next question. And it's a different type of problem. Now, if you wanted the same type of problem, you could just go back to number 1 and do a similar problem. So let's see if I can get a similar problem here. Let's see, maybe it's not giving me an option here. You can get similar problems. It won't just give you one problem. So you'll have to play with it and see. We'll go on though. All right, so you're gonna select this. This is an interval. It looks like an ordered pair, I know, but it's an interval. And so they wanna know, how do you write this as an inequality? And the way you would write it as an inequality is this second one, but I'm gonna pick the first one, which is wrong. Okay, because I want you to see what happens when you pick a wrong answer. So I picked the wrong answer, and on this one, I'm just gonna pick anything. All right, and now I'm gonna check my work, which is wrong, and let's see what it says. It says, recall the meaning of a parenthesis and a bracket in interval notation. So it is not right, so we get the opportunity to try it again. Pretty cool, right? So we would try it again. We would probably do it until we get it right. If we still can't do it, we might want to look at it step by step. This is a guided step-by-step problem. So see how it says I didn't do number 2, but it's letting me go on. So anyhow, I just wanted to show you this. This is going to be very valuable to you because, like I said, your test questions are going to look like this. And not only that, but you get to practice on how do you put this format online. So what is the symbols that you have to put together online? All right, so that's the evaluate. So far in your book and your online textbook, you're mostly interested in explore, explain, and the evaluate. Okay, now what I want to do is I want to show you what resources are available to you. So this right here is your student edition. So this looks just like what you're holding in your hand. It's exactly what you have in your hand. All right, so I want to look at the problems. I will be assigning the problems out of the book. So see this evaluate, homework, and practice. Okay, so this right here is your actual assignment in your book. There may not be enough room to show your work because here they're asking for 3 notations. Don't shove it into a little space. You want to get a separate sheet of paper if you do not have enough space to do the assignment. All right, this practice AB, you can print this or you can write it out. This is actually extra practice that I assign a lot of times. A is easier than B, but this is just extra practice that sometimes I assign. All right, now this is what I want to show you. This resource locker has videos. So let's look for a lesson from a different teacher. Let's say you can't stand me and you don't understand what I'm teaching. Let's see what Dr. Berger is going to say. So you can actually hear the lesson from a different teacher. All right, can you hear me?
Yeah.
Hello? Okay, he's erasing the way I like. That other notation is really weird to me and you never see it written like that. So the one that he's erasing is the one that you're gonna, when I teach this lesson, you're gonna see me write it that way because everybody in the world writes it that way. So he should have left it. Dr. Berger, you should have left that because that was way better. But anyhow, I just wanted to show you these videos that you have access to at your fingertips. Also, there's digital and printout resources. And if you click on that, these are selected answers. Now, I am going to put answers in Classroom for Module 1. But if you look at these answers, these are some of the odd answers in Lesson 1.1. So there's some selected answers in here if you want to look at that. And then if you want to look at some tools, there's a graphing calculator online, there's a scientific calculator, geometry sketcher, and a bunch of different tools that are at your fingertips. So anyhow, I just wanted to show you some of what you're going to have accessible to you with your interactive textbook. So really cool stuff. You can mess with it and see what you have, but I just wanted to show you some of the things that are there. And I think the most powerful thing is being able to work problems and have the computer check your work. So that's a very, very powerful tool that the publisher developed and made accessible to you. So anyhow, What I was going to do right now is I was going to start on the lesson. Does anybody want to ask me any questions about the interactive textbook? All right, I'm going to start on this lesson then. This is lesson 1.1 in module 1. This lesson does have to do with domain and range and writing it with 3 notations, inequality notation, set notation, and interval notation, which is what we use most in Algebra 2 and pre-calculus. And then I'm going to get into the end behavior. Okay, one thing that I want you to be aware of in your physical book, I want you to know that there's a lot of errors in your book. So don't think that you're wrong. If you have a question about something, ask me, but there are a lot of errors in your book. I don't know if they were concentrating on Algebra 1 and geometry so much that they failed to really look closely at Algebra 2, but there are a lot of errors. Once again, I am modeling what I want you to do in your lesson. And so make sure that you're trying to do as much of what I'm doing as possible when we're talking about notation. All right, so here we go. So you're taking notes on this, right? All right, so this is lesson 1.1, and it's the California Common Core Standard F-IF.5. Okay, now sometimes I'll tell you to look at the Explorer and sometimes I'll tell you don't look at it, but in this case, I do want you to look and do the Explorer. Okay, remember the Explorer is one of the first topics in your book there. All right, so with this lesson, we want to look at notations. And in particular, we want to look at inequality notation, set notation, and interval notation. And like I said, interval notation is going to be the most important to us. And just know that an interval is exactly what it says. It is a range of values. And you'll see that when I do this example right now. So, all right, I'm going to erase this. Let's look at an example. So you have a number line. Pretend those are equally spaced. And I'm going to do the graph in a different color. And this is what it looks like. Actually, it doesn't look like that. It's going to stop at 3 open. I'll do that arrow one in a minute. All right, so what I've represented here is I've represented an interval from -2 to 3. Now, let's talk about this first. Remember, closed means the number is included and you can hit -2. Open means you cannot hit it. You become infinitely close to it. So 2.9999999 is okay, but 3 is not okay. So this represents an infinite number of answers because there's answers in here like 1.1, 1 3/4, 1 9/8, 2.135. So all of these answers in here denoted by that pink bar are all answers on this number line. So let's take a look at the inequality. This is the one that you're most familiar with. And when you're writing an interval, you're going to use these symbols. Okay, never use these, and the answer is because you can't. So intervals are only represented with less thans, and the variable goes in the middle. So we would read this as x less than 3. So you're reading it this way, x is less than 3, and you would read this one the other way, x is greater than or equal to -2. So I'll say that again. A lot of people read math like English. You do not read math like English. You read the variable first. So you would read this as x is less than 3 and x is greater than or equal to -2. So that is the proper way to read this. Just remember, read the variable first. All right, now set notation is a fancy notation. It's a very formal notation. And I want to show you how to draw these curly brackets. So to draw a curly bracket, you're going to draw an S and a 2. And to draw the right one, you're going to draw a 2 and an S. I know, this is great, right? A student taught me how to do that, and I love it. It's the best thing I'm going to teach all year. So yeah, I know. I'll do it again. So to draw the left one, you're going to draw an S and a 2. And for the right curly bracket, you're going to draw a 2 and an S. All right. So what Dr. Berger said was true. This is the set of all x values such that, and all you do is put the inequality in there. That's it. So we have the set of all values of x such that x is less than 3 and x is greater than or equal to -2. So let's take a look at interval notation now. Interval notation can best be seen from a graph if you have it. So if we look at the graph, the square bracket means it's closed. The open parenthesis means it's open. And all you do is put the values in, -2 and 3. So this is showing an interval that's closed on -2 up to 3 open. All right, let's do another problem over here. Okay, let's make this one a little bit different. We'll do an open on 2, and we're gonna make the solutions going forever to the right. Now you do understand what that arrow means, right? When you have a closed arrow, it means forever to the right. So basically what this is saying, these are all the solutions that are greater than 2 to infinity. All right, so let's do the inequality notation. Now, we can write it like this, like Dr. Berger was going to do, but it's ridiculous. Most people in the world are going to write it like this. They're going to write it as x greater than 2. Now, your book is going to show this a different way. Dr. Berger was showing it a different way. You could do it a different way, but nobody in the world does it like that I know of. So, as far as set notation goes, it would be the set of all x such that x is greater than 2. And then finally, the interval notation would be open on 2, and infinity can't be closed. So it'd just be 2 to infinity. Now let me make a comment here. Negative infinity always goes on the left in the interval. Positive infinity always goes to the right. They're never going to be switched. Negative infinity always goes to the left side. Positive infinity is always on the right side. Okay, does anybody have any questions? Okay, are you guys okay? Or does anybody want me to work another problem?
Can you do one more?
Sure. How about we do a harder one? You guys are honors. So check this one out. This graph is going to have two parts. It's going to have a part of the graph is doing this, and the other part is doing this, open, going to the left, forever. And they want you to write this in the three different notations. So we'll start with the inequality. So basically what this says is it says that x is strictly less than -2 or x is greater than or equal to 1. And if you want to get really fancy, you could change this word or to a union, because a union means or. Set notation. Just going to put this stuff in there. So we're going to say the set of all x such that, and just put this in there, x less than -2 or x greater than or equal to 1. And then finally, the interval notation is going to be, this guy is going to be open and open, and this guy's going to be closed and open. So this would be, looking at the graph, this would be -infinity up to -2 open, or closed on 1 to infinity. Okay, I'm going to change this to grid view here. Can you guys give me a thumbs up, please, if you understand what's going on? Are we totally lost? Or I feel like I'm doing a pretty good job right now. So I'm hoping everybody understands what's going on. Are you guys okay? Yeah, I love days when I'm speaking perfectly clear. So today's one of those days where I feel like I'm pretty clear about what's going on. So there's some days, and you'll see, when my tongue gets twisted and I can't put any sentences together and I'm making all kinds of mistakes, and so I have those days too. Do you guys have a question about this problem? All right, let's go on then. All right. So basically what I've done so far is I've just talked about three notations, inequality notation, set notation, and interval notation. Now I want to talk about domain, range, and in behavior. So the domain is basically where the graph exists left and right. So formally, it's the set of input values known as X. The range is where the graph exists up and down. And formally, it's the set of output values, Y. And now we have the end behavior. This describes what happens on the far right and far left of the graph. Okay, so I'm going to write the directions over here and we're going to work a problem and I'm going to erase these. This is the vocabulary. So here's the directions on the problem. It says write the domain and range as an inequality, the three notations, set an interval, then state the end behavior. Now, like I said, in your assignment, if you're using the assignment pages in your book, you can write in your book. It's your book. Now, when I give the assignment, you're going to want to rip the pages out and put it in your assignment section, right? But if there's not enough room to show your work in your book, use a sheet of paper to make sure you show all your work. Do not leave the pages of your assignment in the book. Rip them out and put them in the assignment section of your notebook. So in class, normally that's what we do. You know, I'll tell everybody, okay, rip out module 1. And then we do lesson 1, they take it out of their notebook. We do lesson 1, 2, they take it out of their notebook. So I'm going to tell you, rip module 1 out of your book. And I'm going to be assigning assignment lesson 1, 1. And you will put that in the assignment section of your notebook. All right. And you're going to see why now. You may not have enough space. So those are the directions. And here's the problem. Yeah, it looks like a quadratic. So we're going to start with the domain. And we're going to start with inequality notation. All right, you guys. The domain is where the graph exists left and right. So if you take your pencils, don't look up and down, look left and right. So you guys do realize that this is going to run off the board and up on my wall, right? It goes right forever, goes up forever, but it goes right forever also. And if you go this way to the left, this graph it's not only going up forever, it is going to the left forever. So not only is it going up forever, it's going to the left and right forever. Okay, so the question is, what is the domain then? So where does the graph exist, left and right? I should have put this in the definition. You could put it in. Just keep focused that domain is left and right. So if we were doing the inequality, this graph goes from negative infinity to infinity, forever left and right. The set notation would be the set of all x such that it goes forever left and right. And the interval notation would be open on negative infinity up to infinity, forever left and right. So let's talk about the range now. Now the range is where the graph exists up and down. So the best recommendation I can give you on this assignment, and you're gonna have to deal with this throughout this entire class. They're always asking for domain and range, domain and range, domain and range, and in behavior. Domain is left and right, range is up and down. So basically we want to know what are the y values that exist for this graph. In other words, where does the graph exist up and down? So we're dealing with y now, and this graph doesn't exist up and down forever. There is no graph down here, right? So this graph starts existing at 0. So would we say the graph exists at y greater than or equal to 0? See, look, doesn't exist, no, 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 yes, up forever. That was the inequality notation. A lot of work. The set notation is all y now, such that y is greater than or equal to 0. And I'll put the interval over here since we're out of room. The interval would be closed on 0, open forever to infinity. So closed on 0, up forever to infinity. Okay, now what is this in behavior business? All right. This, you guys, it's a very specific notation. So let me show you. It goes like this. As x goes to the right forever, what is the graph doing? What is y doing? So f of x is function notation. F of x represents y. And remember, y is up and down. The other part of this is as x goes to the left forever, what's the function doing? So you're always writing that. Okay, so I'll explain it again. The first one says, as you're walking to positive infinity, what is the graph doing? So that's what that means. As you walk to positive infinity, what's y doing? Is y going up or down at the end? Go ahead, you can answer. As you walk to the right, what is the y value doing? Is it going up or down?
Up.
Up, forever. Okay, here we go with the next part. As we walk to the left forever, what is the y value doing? So as we walk to the left forever, what is the y value doing? What is the graph doing?
Up.
Yep. So that's the in behavior. So like I said, there's a lot of work. Do not shove it in a little place. If you need to write it on paper, write it on paper. I don't want mistakes because you shove something into a little space. All right, does anybody want to ask me about this? We'll do another example. Anybody want to ask me about this one? No? Now, I don't know if you heard me say this, but this domain range and in behavior is going to be throughout this entire course. So it's very important that you understand this. If you don't, you need to talk to me or find out from somebody else. But this stuff isn't going to go away. I mean, they're going to ask you this type of stuff all the time. So let's take a look at another quadratic. This time it looks like this. All right, so the domain, we want the three different notations. Eventually, you know what? I'm just going to abbreviate this now. I'm not going to write this all out. So the domain, actually, I'll write the domain. The other ones I'll abbreviate. Okay, so for the inequality notation, what is the inequality of the domain? Well, this goes forever left and right. So it's going down forever, but it's going to the right forever. And this one's also going down forever, but it's also going to the left forever. So the how do you spell inequality? I-N? Sorry. That's why I'm not an English major. All right. The inequality would be all x less than infinity greater than negative infinity. The set notation would be all x such that x is less than infinity and greater than negative infinity. The interval notation would be open on negative infinity up to infinity. Now we're looking at the range. Range has to do with up and down. So the range for interval notation would be all y. Remember, you have to write it like this, right? So it's all y less than or equal to 0, greater than negative infinity. And remember, we didn't like writing it that way. You can if you want, you could write it that way. You could also write it like this: all y less than or equal to 0. Right? Closed on 0 down forever. All y less than or equal to 0. For the set notation, we would say all y such that y is less than or equal to 0. For the interval notation, we would say, okay, this thing is going down forever and it's going up to 0 closed. And then the in behavior, remember, this is always as x goes to the right forever, y is doing what? As x goes to the left forever, y is doing what? Okay, so look up here, please, with me. So as we walk to the right forever toward infinity, what is y doing? Is it going up or down?
Down.
Negative infinity. Okay, as we walk to negative infinity, so as we walk this way, what is the graph doing? Is it going up or is it going down? Go ahead. Yoo-hoo.
Down.
Down. All right, now I can do another. Do you guys want to see another example within behavior? Okay, does anybody want to ask me an example about domain and range in the 3 notations? All right, would anyone like me to do another example within behavior with a different type of graph?
Yeah.
All right. Okay, this time I'm going to write a function that doesn't have an equation that does not have an equation that I know of. So look at my function. Remember, a function passes the vertical line test. So look at my function. So my function passes the vertical line test. I don't know what it is. It looks like it might be, like a 5th degree polynomial. Maybe a 5th degree polynomial, but who cares what it is? Let's look at the in behavior. As x goes to the right forever, what is the function doing? As x goes to the left forever, what is the y value doing? All right, you ready? So as you go to positive infinity, what is the function doing? So you're walking this way forever. So as you walk to the right forever, what's the function doing? Is the function going up or is the function going down?
It's both.
Down.
Down.
Wait a minute. You're looking at the far right. So when you look at the far right, isn't the function going down?
Yeah.
Okay, now, as we walk to the left forever, see this arrow? It means forever, right? What's the graph doing? Is the graph going up or down when we walk to the left forever?
Up.
It's going up. Okay, I'm not sure if you're just not talking to me or if there's a delay. Do you guys want to do another one?
Yeah. Can we do another one?
Ready? As we go to the right forever, what is the function doing? So as we walk to the right forever, what is the graph doing?
Up.
Going up.
Up.
As we go to the left forever, what is the graph doing?
Going up.
It stops.
It stops. So listen to this. If I said you have really bad behavior, aren't I talking about like in general? I'm not talking about just for the day. I'm saying that overall your behavior is just bad, right? So behavior is something that's ongoing. So if it stops, there is no behavior. Because it's not ongoing. So this is not an arrow, it stops. So there is no behavior. It's not going up forever, it's not going down forever, there's no behavior. Okay, go ahead, I'll take questions. I'm not done with the lesson yet, but you can get started on these exercises. I haven't made a due date yet. If you look at your book and you look at the exercises, I'll tell you what page. On page 12, I'm going to be assigning all these problems 1 through 12. Now, I've taught a lot, but I haven't finished the lesson. All right, so I haven't talked about restricting the domain. And I haven't done any word problems. All right, anybody want to ask me a question or anybody want to ask me about domain, range, or end behavior? Okay, does anybody have a question about the problems on the board? I'm going to erase them. If you don't have a question, I'm going to erase them. Ask me now. Here's what I don't want to happen. I don't want to end the meeting and then I have 100 questions. That's not fair to me. You know what I mean? It's like, if you have a question, ask me now. Now's the time to ask me. And if you're thinking, well, I'll just figure it out. I'll just figure it out later. No, you're not. You're not going to figure it out later. So the best thing to do is ask me and let me clear it up in 1 second. Okay, so let me clear it up in 1 second. What do you have a question about?
Ms. Birch, you know, in the intervals, when do you use the brackets and the parentheses? Because in some of them you use parentheses and others you don't.
Yeah. You and about 100 other people don't get it. So I'm glad you asked. That's actually one of the most, I know what you're going to mess up on, but you're going to have to ask me. I'm not going to do everything to me. But that question right there, a lot of people want to know that answer. So I'm going to show you. All right. By the way, do not draw a number line above, you draw on the number line. There's some teachers at the middle school that are allowing kids to draw the graphs up. Don't, you draw on the number line. All right, now look at this. When you have an open, you have to use a square bracket. When you have a I'm sorry, that's a lie. That's the wrong one. When you have an open, you have to use a parenthesis. When you have a closed, you use a square bracket. Now, in this case, since you would use this open parenthesis. Since this one's going off to the left, you would use this one. So the answer to this would be open, closed. So it'd be open on 1. This is a parenthesis, by the way. Up 1 to 5. So see how 1 is open and 5 is closed?
Yeah.
So pretty simple once you see it. It's just that nobody sees it at first. Okay, did that help?
Yep.
Okay, cool. And thank you for asking, because you just helped about 20 other people. So thanks for asking.
And I have another one. When we were doing the graphs, you also use the brackets and the parentheses. Like on the first example, you use bracket 0, comma, infinity, and then parentheses.
You're breaking up a little bit. What problem was that?
That was the first one we did.
The parabola, this one?
Yeah, that one.
And you're talking about domain, range, or end behavior?
In range.
Okay. With the inequality notation, you're okay with that one or no?
Yeah, I just need the interval one because it's the same thing here with the brackets and the parentheses.
Okay. So the interval one is, you see how this graph goes forever up and to the right, and this graph goes forever up and to the left? So it's going, when you write the interval for domain, for the range, you're talking about up and down. So remember, domain would be negative infinity to infinity. So the domain is negative infinity to infinity, but the range, see how it stops here? So it'd be closed on 0 up forever. So one way to do it is like this. When you're doing domain, take your pencil and go like this. When you're doing the range, take your pen and go like this. So see how this, it doesn't exist down here, and it exists closed on 0 up forever. So closed on 0 up forever. The domain is forever left and right. The range is closed on 0 up forever. Am I making myself clear or no?
So since infinity never stops, you would use the parentheses?
Yeah, you're never going to close negative infinity. And not only that, but when you do negative infinity, make sure he's always on the left, and positive infinity is always on the right. Never put positive infinity never goes on the left, and negative infinity never goes on the right.
So say the y ended at like 5, you would close it off with a bracket?
Yes. If this graph ended at 5, it would be closed on 0 to 5, closed.
Okay, that cleared it up. Thank you.
Okay, you're welcome. Hey, listen, I'm going to turn off the recording. You're welcome to hang out with me if you want for a couple minutes. I do have another class, but let me turn off the recorder. I hope you guys have a great day. Have a good weekend, okay? Let me know if you're having any problems, but I'm going to turn off the recorder now.